Let's talk about the Bitcoin transaction system. But before we actually talk about the Bitcoin transaction system, what we need to understand is what exactly is blockchain. Blockchain basically is the core technology behind Bitcoin in itself. You can say it is the spine of Bitcoin system. To put it quite simply, blockchain is actually a public distributed database which holds the encrypted ledger. So why is it encrypted? To keep the details of the people involved in it completely anonymous. Apart from this, what exactly is a block, you might be wondering. A block is a collection of all the recent transactions that have happened and are verified. You group all these transaction details, create a hash code for this, and then you store it in a block. Once the transaction is verified, then what happens is this block becomes a permanent part of the blockchain and the chain keeps growing. So it is believed that every 10 minutes a new block gets created and the blockchain keeps growing accordingly. So how many transactions happen with respect to that time frame? All can be grouped as part of the block and then stored into the blockchain's block. But then again, you might be wondering what exactly is Bitcoin in itself. So don't worry, that's exactly what we're talking about next. Now Bitcoin is the first decentralized digital currency that came into the market and was introduced in 2009 by a pseudonym called Satoshi Nakamoto. Now he brought in the concept of Bitcoin and blockchain together in an open paper, and this was something of a revolution. It was not until July 2009 the first blockchain came into implementation and became quite popular since then. Now you may be wondering, since it's a decentralized and a digital currency, can't we just keep creating bitcoins as per our needs? The answer is no. Bitcoins use various cryptographic as well as mathematical problems that ensure that the creation as well as management of bitcoins is restricted. Now, there are only 21 million bitcoins that can be created, and as on 2016, we've almost created 14 million of them. So what Bitcoin community has done is that they keep upgrading the algorithms as well as cryptographic technologies involved in Bitcoin on a regular basis. This ensures that even if there are more miners that come into the Bitcoin technology every day, that the Bitcoin system does not get exhausted. With the increase of complexity, it ensures that only by 2140 does the last Bitcoin get mined. Apart from this, the ledger system, which keeps a track of how much Bitcoin gets transacted, is in itself completely electronic and highly secure. Now, if you need to change any specific transactions, let's say you are trying to send someone Bitcoins that you don't have. Let's say I want to send 500 Bitcoins to every one of you who are part of this session. This becomes impossible, because the ledger in itself is completely electronic, as well as every transaction is verified and validated before it gets added to the block. Now going back to our previous topic, that was blockchain. Now in a block there are mainly three key concepts. The first is the previous block's hash code. Now every block has a specific hash code associated with it, which is used as an identifying factor for that block. Now this hash is something that gets created with a very complex hashing algorithm, where even a minute change with respect to the input can create a highly different hash output as whole. Now, you cannot reverse engineer this hash code as well. The algorithm is created in such a way that no one can actually get the complete data by reverse engineering the hash code as well. Apart from this, you have the complete hash details of every transaction that has happened as part of that block. Now, there could be multiple transactions that happen at one go. So every verified and validated transaction gets added to block, with thereby ensuring that this transaction cannot be manipulated. Apart from this, the third thing that needs to be part of a block is basically the value or proof of work for that block. This basically is a mathematical solution that you attach with the block to ensure that this is a valid block. Now, we're not going to go in detail with respect to the mathematical proof, but we'll talk about that in the upcoming slides. Now you may be wondering, since it is a ledger and everyone has access to it, can I just not directly modify the ledger or the transaction? Definitely not. These ledgers are something that gets created by softwares which in itself have to solve a mathematical problem to get the valid output. So as I had mentioned, all the output gets hashed, and this hash value is what becomes a proof of work. So even if you try to falsify, or even if you try to fake a specific transaction or a detail with respect to the ledger, it is not going to get accepted. Apart from that, since the ledger in itself gets distributed throughout the network, everyone has a valid copy of the same. Let's say if you try to change even one specific transaction which is part of the block, it does not get accepted because majority of the people of the network have a copy of the block which is valid. So your modified block or transaction gets completely rejected and does not become part of the original blockchain as a whole, thereby ensuring that every transaction as well as every block is highly secure as well as valid and verified. So moving forward, let's try to understand how a Bitcoin transaction takes place. Now let's take a group of 8 people who are part of my blockchain network. Okay, you have James, you have Steven, you have Rahul, Kevin, Paul, Robert and Lisa. Now James wants to transfer 500 Bitcoins from his account to Kevin's account. Now just because James wants to transfer 500 Bitcoins to Kevin's, it may not seem possible. To give you a better example, let's say I want to give every one of you who are part of this session 5 crore rupees. Sadly, I don't have enough balance, so I can't do that. But that same thing needs to be validated by someone else. And that's exactly what the role is of Robert and Lisa, who are special professionals called miners. Their main job is to see whether James actually has enough sufficient balance. Now, there are a lot of protocols as well as security features that come into this, and we'll be talking about each one of them one by one. James here wants to transfer 500 Bitcoins to Kevin, and Lisa and Robert's job is to verify that they have sufficient balance. Now, before we go on, let's look at a sample ledger here. Here you have account number as well as the balance that is there after each transaction takes place. Now, this balance gets updated every time a transaction gets introduced, and the ledger in itself gets updated with respect to every transaction. So here, rather than having the details with respect to one single account, you store the details with respect to the transaction as part of the block. This again ensures that even though there are details with respect to the transaction available, you cannot directly attack or hack the end user and take away his money from his wallet. Although there are different kinds of cryptocurrency system in the market today, to give you a simple example, blockchain system actually keeps count of the unspent transaction output, whereas your systems like Go Ethereum follows an account-based system where an account balance is also stored. So based on different kinds of requirements by the user, you have different kinds of blockchain in itself. But we're going to be talking mainly about Bitcoin blockchain itself. So we'll be talking about the unspent transaction output. That is the amount of Bitcoins that are unspent. Now before we move forward, let's assume that the third entry present here is of James, who has to send 500 Bitcoins to Kevin. So I'll take this entry to be Kevin's. Okay, I hope all of you can see this. Now here what needs to be done is that 500 Bitcoins has to be taken from this account and has to get transferred to this account. Now if the transaction is successful, since James has sufficient balance, the transaction will definitely go forward and the account balance of Kevin gets updated with respect to everyone who holds the copy of the ledger. That is, this transaction is successful, gets broadcasted to everyone across the network who's part of the blockchain, and they themselves update their ledger accordingly. But then you might be wondering, whose job is it to verify that this transaction goes through and James has sufficient balance? That exactly is what the job role of miners Lisa and Robert is, as we have discussed earlier. Now what is going to happen is that Lisa and Robert are in turn going to check the complete transaction history of James. They're going to see if at any point James has received more than 500 Bitcoins or at least holds a corresponding previous balance of above 500 Bitcoins. So let's say there has been a scenario where Rahul had sent him 600 Bitcoins. So this in turn makes it quite easy, and you can immediately see that, okay, he has received 600 Bitcoins. So I don't need to look any more further. I can definitely ensure that this transaction can go through, since James has not spent it also. But let's say James has received from Steven, let's say 200 Bitcoins, Rahul has sent him 100. So I need to keep checking all the previous transactions to verify that he has sufficient balance, including his credit as well as debit history, and then decide whether this transaction can go through. Now this is exactly what Lisa and Robert as miners do. Now once they have validated that James has sufficient balance in his account to transfer 500 Bitcoins to Kevin, then what happens is that this transaction gets added as part of the block. And once the block in itself gets validated, the money gets reduced from James's account and goes to Kevin's Bitcoin account. Now usually this whole process of a block validation gets completed in 10 minutes, but it is suggested that you wait about 30 minutes to confirm a transaction. Now again, since every transaction gets validated by a miner, they go back to all their previous history and keep checking. Now let's say James at the same time had tried to send 500 to Kevin and 500 to Rahul, having only 500 as part of his balance, then what would happen is, since each transaction is individually being checked, the transactions would go through one by one. Now since James has sent Kevin 500 bitcoins, the transaction which is sent from James to Rahul won't go through because he recently just spent 500 bitcoins and he only had 500 bitcoins as part of his Bitcoin wallet. So therein it completely avoids the problem of double spending that we had discussed earlier. So are you guys clear with respect to how a Bitcoin transaction system takes place? Why would Lisa and Robert actually sit down and validate their transactions? What do they have to gain? The miners who validate the transaction as well as complete the next block of the blockchain get a 12.5 Bitcoin as an incentive for the creation of the new block. Now this is something that gets created out of thin air and gets added to their Bitcoin wallet associated to it. Now 12.5 Bitcoins is not a small amount. In today's value, it's somewhere about $33,000 to $34,000, which is a very huge amount. And you also need to understand that almost every 10 minutes a new block gets created and becomes a part of blockchain. So you can assume that every 10 minutes $33,000 gets credited into someone's account. But it's not as simple as you think. Mining requires a lot of investment, and as I had mentioned, it's not easy for one single person to mine the resource. So in today's world, what happens is a lot of miners come together and form something known as a pool. These people invest all the resource that they have to solve the pool together, and based on how much resource that they have invested in mining the pool, reward gets distributed accordingly. Now let's take a real-time scenario, $33,000, and let's say there are 11 people as part of that. Each one gets close to $3,000 in itself. $3,000 again is a huge amount for something that requires 10 minutes to mine. But again, let's not go into how much efficient it is to mine the resource and all that. We will talk about that in the upcoming sessions as well. But just to give you a simple idea, there's an incentive also added to Lisa and Robert. Now, again, there are a lot of sites that help you do this. But again, what I would request you is to check whether you're actually going to get any profit before you become a miner. Because again, the resource needed for mining a block is not less, and day by day it keeps increasing as well, because the complexity involved in solving a block keeps growing day by day. As we had mentioned earlier, there is a certain level of complexity that is involved in mining, and this keeps growing as time goes, because a lot more people are mining today when compared to 6 or 8 months back, and this is mainly because of their attraction for the incentives. But at the same time, since more miners are coming, we need to ensure that the Bitcoin system does not get depleted. As I had mentioned earlier, there's only 21 million Bitcoins that can be mined. So the system in itself makes it difficult for you to compute the resource. And as I had mentioned, just check how efficient it would be for you to become a miner.